Okay, so now let us look at those three sequences and then to check whether the sequence. Okay, so let's take a look. The first sequence, an is 1 minus 7 and 7 to the power of n over n here. We know that to check whether a sequence, okay, so given a sequence, so whether it converge or diverge, all we need to do is to check whether this limit exists or not. Okay. So so sequence converge or diverge, we need to check whether this limit exists or not. So look at the first one, limit as n goes to infinity, an is limit 1 minus 7n over n here. Okay. So we know that this is 1, this is easy, it's just a minus limit 7n over n. Okay, so it turns out this is an infinity over infinity format. What we can do is we can apply the L'Hopital rule to do that. So it's 1 minus limit, so the derivative of the top actually is 7n times ln of 7 over 1, okay, over 1. So do you agree that as n goes to infinity, this goes to infinity, right? So there's negative there. So it turns out that limit of this n goes to negative infinity. Hence, the sequence, okay, diverges. Okay, diverges. So that's based on the definition here. So that's our main conclusion here. Look at the second one. So Bn equals n factorial over n to the power of n here, okay. And it looks like we need to verify this, okay. Okay, and how do we verify this one? It turns out that you can see, guys, if we expand the top and bottom, so this is 1, 2, 3, 4, up to n. But on the bottom is n, right? For here. So do you agree that, guys, as n become very large, do you realize that this part actually is going to be less than 1? Right, it's going to be less than 1. In other words, guys, all of these pieces is less than limit n goes to infinity 1 over n. Okay, because this bunch of part is less than 1 over n. And we know that this limit equals 0. Okay, or less or equal to that. Let's do that. And meanwhile, I also know that my Bn is also greater or equal than 0. Okay, so this limit, so it turns out limit n factorial over n to the power n is less or equal than 0, greater or equal than 0 also. So that means limit n goes to infinity, n factorial over n to the power n, it must be a 0. Based on the sandwich theorem, right? Remember, if the limit is greater or equal than number, less or equal than the same number, then that limit must be that number. So that's what we call the sandwich theorem. So that means my sequence converges. Okay. Not only converges, but also converges to 0. Okay. So that's the part B. Look at the part C here. Now, sequence Cn is 4n squared over 5n minus 2 times sine of 1 over n. Okay, so this 4n squared over 5n minus 2 times sine of 1 over n. Okay, Okay, it turns out as n goes to infinity, if you look at evaluate this part, it's gonna give you is infinity, okay? Because on the top it's n squared. And as n goes to infinity, 1 over n will goes to 0. So sine of 0 actually is 0. So this is an infinity times 0 format. Okay. So what we can do is we can also using the L'Hopital rule to handle this problem. So we can convert it into a 0 over 0 type, which is sine 1 over n over, which is 5n minus 2 over 4n squared. Okay, over 4n squared. And okay, so in that case, this is 0, this is also 0. Okay, now we can, since we are focusing on as n goes to infinity, so also you can see that we actually can drop this -2, because as n goes to infinity, this gonna behave, I would say, almost the same like this one. Okay, so the limit of this part becomes sine of 1 over n over 5 over 4n, okay, over 4n. And even more, we can do, we actually can take this as 4 over 5 times sine of 1 over n over 1 over n. Okay, over 1 over n. So basically I bring this out. So let me use this space here. So it turns out this is going to be 4 over 5 limit sine of 1 over n over 1 over n. So this is a very standard 0 over 0 type. So we can apply the L'Hopital rule again, which is going to give us cosine of 1 over n, right, times -1 over n squared, which is the derivative of this 1 over n, and over -1 over n squared, which is the derivative of this 1 over n. So do you see that those two can cancel out? Now what we have here is 4 over 5 times limit n goes to infinity cosine of 1 over n. And we know that as n goes to infinity, 1 over n is 0, cosine of 0 equals 1, so this limit equals 4 over 5, okay? So it turns out that the series also converges, this sequence, my bad. So sequence converges, and not only converges, actually it converges to 4 over 5, okay? So those are three sequence examples, okay? And so hope you, so you can see that this is from the first, second, and the third, okay? Three very standard sequence example. You know, the L'Hopital rule can be a game changer. So yeah, hope you enjoy this video, and thank you for watching.